This video will summarize the four kinematic equations and work through an example problem. So first, let's go back and recall hold on, sorry, there we go, there's my pen. Let's recall that we had basically 5 variables that we're using. D for displacement, V initial for our initial velocity, V final for the final velocity, A for acceleration, and T for time. And we have the four kinematic equations. Let me just write these up here. And you should also have these. You can put this on your note card. And finally, our last kinematic equation. And I keep on wanting to write x. Sorry about that. Our last final kinematic equation is here. So here's our four kinematic equations. And something that I want you to notice is that in each of these four kinematic equations, there are 4 variables out of a total of 5. So to use the kinematic equations, if there's 4 variables in the equation, you need to know 3 of the 4 variables. So when solving a problem, what you're basically doing is looking at the given information, looking for what you're trying to solve for, and deciding which of these 4 equations would be helpful to use. So let's take a look at this first one. This is actually problem number 3 from the problems that were on the back of that sheet. This is about spud guns. So according to Wikipedia, the highest speed ever recorded for a potato being launched from a spud gun is 820 meters per second. Let's assume that the length of this gun is about 1 meter. Assuming the potato is uniformly accelerated, how long does it take the potato to travel the length of the spud gun? So let's first think about what we've been given. We're talking about this spud gun launching a potato at 820 meters per second. Okay, so it's launching it, and we're looking at that it's uniformly accelerated, and we're interested in the time that it takes to travel the length of the spud gun, which is 1 meter. So it seems that the 820 meters per second must be our final velocity. And if we're talking about a spud gun being launched, that initial velocity must be 0. Often you might look at a problem and think that you don't have enough information, and it's possible that either the initial or final velocity is 0. So we've got the final velocity, initial velocity. We know that displacement is 1 meter, and we're looking for the time. Okay, so we go back and we look up at these equations, and we notice that none of them directly solve for the time. So it's not necessarily going to have a t equals something, but what we're looking for is the equation that has the 3 variables we know and the 1 variable we don't know. So v final, v initial, d, and t. V final, V initial, V final, V initial, D, and T. So it makes sense that we'd be using this second kinematic equation. So I go ahead and write down that kinematic equation. And then I need to rearrange my equation to solve for T. So I'm going to multiply each side by 2. And I get this, and then I can divide each side by V initial plus V final. So I get 2D over V initial plus V final. And then I've got 2 times 1 meter over my initial was 0 plus the 820 meters per second. and that gives me some fraction of, all right, so we take 2 divided by 820, and we get 0.00243 dot dot dot. And given that the length of the gun is about a meter, we really can only give our answer to one significant figure. So our answer should be 0.002 seconds. And that's the time that it takes the potato to travel the length of the gun. So again, key things to remember. You're thinking about drawing the picture, reading through the problem, writing down your initial information and what you're looking for, and then you just take a look at the kinematic equations if it's something that seems like you've got some of that information and you're missing something. You look at the kinematic equations, pick the appropriate one, and then just solve for your time. That would be it. Good luck with the kinematic equations, and make sure to find me if you have any questions.